In this video, we're going to look at adding and subtracting mixed numbers. Now, I will mention ahead of time here, we could do each of these problems by going through and converting our mixed numbers into fractions, working it out as a fraction problem, and then converting back. Although that's a little bit more work, some people do actually prefer that. Otherwise, we can treat them just as mixed numbers. And the key here is there's just a couple little special rules we have to remember. So first thing, let's write them down vertically, just like we would do if we were adding or subtracting fractions. And just like with adding or subtracting, we need a common denominator. In the case of 3 and 4, that common denominator would be 12. Common denominator would be 12. Now at this point, we need to build our new numerators. So we say, well, 3 times 4 was 12. So on the top, 2 times 4 would give me my new numerator, which is going to be 8. And 4 times 3 is 12. So 3 times 3 would give me my new numerator, which is 9. And at this point, we can go ahead and add. 8 plus 9 is 17 over 12. And we can add the whole numbers. 4 plus 5 is 9. However, that 17 over 12 is an improper fraction, and that's not allowed. When we write a mixed number down, it has to have a proper fraction with the number. So what we have to do here is take that 17/12 and realize, hey, I can convert that to a mixed number. That is 1 and 5 over 12. 1 and 5 over 12, because 12 goes into 17 one time with 5 left over. And then remember, there's really a plus sign there. So that's really 9 plus 1 over 5/12. And then we can add 9 plus 1 is 10, and we get 5/12. Now, in some problems with mixed numbers, this fraction will just already be a proper fraction. In that case, you're done. You don't have to go any further. But if it is an improper fraction, like here, we have to convert it to a mixed number and then simplify. The next example, we want to take a look at an example of subtracting mixed numbers. So my problem here is 5 and 3/8 minus 3 and 4/5. And so I went ahead and wrote these down vertically. 5 and 3/8 minus 3 and 4/5. Just like the last problem, we need to get a common denominator for 8 and 5, which will actually be 40. And then we can build our new numerators. So in the case of 8 times 5 is 40, so 3 times 5 is 15. In the bottom, we'd have to take 5 times 8, so we would do 4 times 8 and get 32. At this point, as we try to subtract, we have a problem. We can't do 15 minus 32. So remember, when you don't have enough to subtract, we have to borrow. So we borrow from the 5. What we've borrowed from the 5 is a whole number, so we're left with 4. Now be careful, that 1 that we borrowed does not go in front of the 15 and make it 115. The 1 we borrowed is actually a whole number, 1. So that's 1 and 3/8, or 1 and 15 over 40. And here we have to use our conversion step to go from a mixed number back to a fraction. We take the whole number 1 times the denominator 40, which would be 40, plus the numerator would be 55. And so the new fraction is 55 over 40. And now we can finally just go ahead and subtract. 55 minus 32 is 23 over 40. 4 minus 3 is 1, so our answer is 1 and 23 over 40. Just like with adding, you don't always have to do this borrowing step, but you do have to be aware of it when you're subtracting mixed numbers.